Hi everyone. In this video, we are going to discuss about how to solve a triangle when two side lengths and the angle opposite to one of the given sides are provided. And this particular case is known as the ambiguous case because there is a possibility that we could have one solution, two solutions, or even no solutions. So let's see how all of that works. Suppose we have a triangle for which we have been given the two side lengths which are B and C, and also we have been given the size of the angle which is opposite to the side B, and that angle is denoted by uppercase B. When we are provided information like this and we are asked to find the three other attributes of this triangle, we have to verify to see if a triangle is even possible. Sometimes a triangle may not be even possible, sometimes there may not be a solution, and sometimes there could be two solutions, and sometimes there could be just one solution. Let's suppose when you draw the side length C and the angle B, they kind of look like this, where the side AB is denoted by the side length C, that is the length of AB, and the angle B has been drawn like this. Let's suppose that that is equal to the angle B which has been provided, and then we have to determine where would be the point C. Now where would be the location of the point C actually depends on the length of the side B or value of B. Let's suppose the value of B is such that when we draw a line from A, it never meets the line segment BX. That means the length is too small. So using the value of B as the radius of a circle, if we draw an arc from the point A, the arc could look like this if the value of B is too small. And then what would be the side B? Well, it could be something like this, or it could be something like this, or even like this, or even like this, or could be something like this. But in any case, you see that that line never meets the line segment BX. That means with that value of B, we will never be able to complete a triangle, meaning we will never be able to draw a triangle. So then the next question is, what is the minimum required length of B, or what is the minimum required value of B so that we can at least draw a triangle? Well, if you think about it, in that case, the length of B should be such that at least it will be equal to the perpendicular distance from A up to the line segment BX. That means if we draw an arc from A, it should touch the line segment BX. And then what would be the side B then? Well, it will be like this. It will be the perpendicular distance of the line segment BX from the point A, and that will be the shortest distance, and that is the minimum required size of B so that we can draw a triangle. And in that case, obviously the side AC will be perpendicular to BX, and then of course the angle C would be a right angle. And what would be sine of the angle B? Well, that will be equal to B over C. And from here, we can say that B will be equal to C times sine of B. And that is the minimum required length of B for us to be able to draw a triangle. So depending on what value we have been given, we have to quickly check and see if B is at least equal to C times sine of B. If B is smaller than C times sine of B, then we will not be able to draw the triangle. If B is at least equal to C times sine of B, then yes, we will be able to draw a triangle, and that will be a right triangle, exactly how we see in the diagram now, the triangle ABC, where B will be equal to C times sine of B, and C will be the right angle. And for this situation, what would be the length of A? Well, cosine of B will be equal to A over C, and from there we can say that A will be equal to C times cosine of B. So when B is at its minimum, then A will be equal to C times cosine of B, and of course B will be equal to C times sine of B. So if we are given an example where you see that B is less than C times sine of B, then the answer would be there is no solution because we will not be able to draw a triangle. So for us to be able to draw a triangle, the minimum required value of B is actually C times sine of B. I hope it is clear up to this point. So essentially we are saying that B has to be equal to at least C times sine of B for us to be able to draw a triangle. So we can denote it like this. Here I have noted that when B is less than C times sine of B, then there is no solution. We cannot even draw a triangle. When B is equal to C times sine of B, then yes, there is one solution, and it is going to be right triangle, the way exactly we see in the diagram here, where angle C will be the right angle. Let me also make another note that this part of the discussion is is with the assumption that B is an acute angle. So here I am going to make a note that B is less than 90 degree. And also we will take up the scenario where B is equal to 90 degree and when B is greater than 90 degree. We will discuss those scenarios as well. But for now our discussion is going on when B is an acute angle which is less than 90 degree. So now let's see what happens when B is greater than C times sine of B. We have already checked two situations here. When B is less than C times sine of B, we know that there is no solution. When B is equal to C times sine of B, we know that there is one solution. It will be a right triangle. And when B is greater than C times sine of B, we want to see what happens. When B is greater than C times sine of B, there are again three possibilities. B could be less than C, B could be equal to C, or B could be even greater than C. Since B is an acute angle, sine of B is a fraction less than 1. Of course, it's a positive fraction but less than 1. And C times sine of B, that is also obviously less than C. And in this condition, B is greater than a fraction of C. So when you say B is greater than a fraction of C, then it could be less than C, it could be equal to C, or even it could be greater than C, right? So let's take those three situations and see how the triangle going to look like. The first situation I'm going to take is when B is less than C, and of course it is greater than C times sine of B, but B is less than C. That is the scenario we are going to check now. When B is less than C, if we draw an arc from point A taking B as the radius, then it is going to cut BX at two different points, and if we join those points, then AC sub 1 would be one of the line segments and AC sub 2 would be another line segment. So the two possible triangles would be ABC sub 1, that is one of the possible solutions, or ABC sub 2, that will be another possible solution. So we have two possible solutions here when B is actually less than C, but B is greater than C times sine of B. Here we are discussing the scenario when B is greater than C times sine of B, but at the same time B is less than C. So when B is less than C, we can clearly see that there are two possible solutions. Now let's see what happens when B is equal to C. When B is equal to C, if we draw an arc from A with the radius B, the arc is going to look like this, and as you can see, the only possible solution here is where I have denoted the point C. So AC can be there, because otherwise if we consider the other point where the arc goes through the point B, if we join AB, then AB and AC, they will become coincident, so that will not give us a solution. So here the only possible solution is exactly the way I have shown in the diagram, that C cannot be coincident on B. In that case the side length A will become 0, so C has to be away from B. So this is the only possible solution here, and in this case the name of the triangle would be ABC. That is the only possible triangle, and I'm going to note that there is only one possible solution. Now let's talk about the third scenario when B is greater than C. When B is greater than C, if we draw an arc from A using the length of B as the radius of this arc, then the arc is going to cut the BX line segment and the extended XB line segment at two different points here. And now if we join point A and C sub 1 and also point A and C sub 2, let's see what happens. We are going to get two triangles like this. One of them will be ABC sub 1 and another one would be ABC sub 2. But if you look at ABC sub 1, that is not going to be an acceptable solution, because in that case the angle B becomes an obtuse angle, but here we are talking about acute angle, right? That means triangle ABC sub 1 is not going to be an acceptable solution. So the only acceptable solution here is triangle ABC sub 2. Next, let's quickly talk about the situation when B is a right angle. I have drawn the diagram here. When B is equal to 90 degree, that means B is a right angle. When the angle B is a right angle, which is equal to 90 degree, then what would be the relationship between the side length B and C? Well, as you can see in the diagram, obviously side length B has to be greater than C. Now, if it is equal to C, then what happens? Then the point C will be coincident on point B and we won't be able to draw a triangle. So for us to be able to draw a triangle, point C has to be away from B, and in that case side length B will always be greater than C. And if side length B is less than C, it will not even complete a triangle. We won't be able to draw the triangle. So in this case, our only option is that side length B has to be greater than side length C. And in that case, obviously there is just one solution, and it is going to be a right triangle where the angle B would be the right angle. Now let's also take a look at the situation when B is an obtuse angle. When B is an obtuse angle, which means angle B is greater than 90 degree, then again we have the only option where if we want to be able to draw a triangle, side length B has to be greater than side length C. If B becomes equal to C, then the point C will be coincident on point B and we won't be able to draw a triangle. That means the side length A will become 0. So for us to be able to draw a triangle, B has to be greater than C. If B is less than C, then we will not be able to complete a triangle. It will not look like a triangle. So the only option is B has to be greater than C. And in that case, of course, there is only one solution. So far, we have completed the geometrical analysis. Now we are going to do some algebraic analysis to see what are the different possible relationship between the side length B and C. For the algebraic analysis, let's use the cosine law. And because we know the angle B, that will be given to us. So because we know the angle B, we can use the cosine law for the B angle, where we can say cosine of B is equal to C squared plus A squared minus B squared over 2CA. And what is the unknown here? Well, here side length B, side length C and the angle B, all of that will be provided to us. So the only unknown here is A. So let's try to find the value of A in terms of the side length B, side length C and the angle B. Now if we multiply both sides by 2CA, then what are we going to get? We are going to get 2 times C times A times cosine of B is equal to C squared plus A squared minus B squared. And if we bring everything to one side, we can write it like this. And then I am going to rearrange it a little bit. So the equation can be written like this. Now this looks like a quadratic equation in A. So from here we are going to use the quadratic formula to find the value of A. So the value of A is going to be like this. And if we simplify this a little bit, we can write it like this. And from here, if we take the number 4 outside of the square root, then we can write the equation like this. Ultimately, we see that the denominator goes away and we get a value of C times cosine of B plus or minus square root of C squared cosine squared of B minus C squared plus B squared. And now we are going to rearrange the terms inside the square root and we are going to write it like this. Ultimately, we see that we have 1 minus cosine squared of B inside the square root and that can be replaced by sine squared of B. That's from the Pythagorean identity of trigonometry. So wherever we have 1 minus cosine squared of B, we are going to write sine squared of B. Then the value of A is going to look like this. Now we are going to do a little bit of analysis on the value of A, assuming B is an acute angle. So our first round of analysis will be on the assumption that B is an acute angle. When B is an acute angle, obviously sine of B will be positive and cosine of B will also be positive. Now, for A to have a real value, obviously the discriminant which is inside the square root, that has to be a non-negative number. So if we look at the discriminant here, the discriminant D is equal to B squared minus C squared times sine squared B. That is our discriminant. And if this discriminant is negative, then obviously A does not have a real value. That means in that case it will be imaginary value of A. That means no solution is possible. We won't be able to draw a triangle. So if the discriminant is negative, if the discriminant is less than 0, there are no solutions. So let's make a note of that. When the discriminant is less than 0, the quantity inside the square root is actually negative. That means we are talking about an imaginary number here. That means A does not have a real value. That means we do not have a solution. And in this case, let's see what is the relationship between B and C. So because discriminant is less than 0, that's the situation we are talking about now. So here we can say B squared minus C squared times sine squared B is less than 0. And that means B squared will be less than C squared times sine squared B. And from here, if we take square root on both sides, assuming B, C and sine of B, they all are positive quantities. So if we take square root on both sides, we can say B is less than C times sine of B. And that's exactly what we saw in our first diagram, that when B is less than C times sine of B, we will not be able to complete the triangle. That means there are no solutions. From the algebraic analysis also, we see that when B is less than C times sine of B, there are actually no solutions. A does not have a real value. That means there are no solutions. Now let's consider the situation when the discriminant is equal to 0. When the discriminant is equal to 0, we can say that B squared minus C squared times sine squared of B is equal to 0. And from here, we can say that B squared is equal to C squared times sine squared of B. And if we take the square root on both sides, then we can say B is equal equal to c times sine of b, and in that case there is only one solution, because if the discriminant is 0, obviously a will have just one value, and that will be c times cosine of b, which is the quantity outside of the square root. Because the square root quantity becomes 0, then there is only one value of a, and that is possible when b is equal to c times sine of b. And we saw that in the geometrical analysis also, that when AC is perpendicular on bx, that is when we had the minimum requirement for b, which is equal to c times sine of b. And when that happens, it becomes a right triangle where the angle c was the 90-degree angle. So this is the situation when there is only one solution, and the solution is a right triangle. And how do we prove that this solution gives us a right triangle? Well, let's see how to prove it. Here, let me quickly make a note that this is going to give us one solution, and that too, it is going to be a right triangle, and we're going to prove that soon. Now, from here, can we also say that sine of b is equal to b over c? Very good. And what would be the value of a? Well, value of a will be c times cosine of b plus or minus the discriminant, and in this case, the discriminant is 0. So I'm going to take this as c times cosine of b, and from here can we then say that cosine of b is equal to a over c. And now if you look at it, we have sine of b is equal to b over c, and cosine of b is equal to a over c. And if we add the square of sine of b and cosine of b, let's see what happens. So now I'm going to say sine squared of b is equal to b squared over c squared, and similarly here if we say cosine squared of b will be equal to a squared over c squared. And now if we add them together, we are going to get sine squared of b plus cosine squared of b, and that will be equal to b squared over c squared plus a squared over c squared. And from here we can say that sine squared of b plus cosine squared of b, that is equal to 1 according to the Pythagorean identity. So 1 is equal to, on the right hand side, LCM would be c squared, and in the numerator we will have b squared plus a squared. So from here we can say then c squared is equal to b squared plus a squared, or we can say that a squared plus b squared is equal to c squared. Now that clearly tells us that it is a right triangle, and it follows the Pythagorean theorem that a squared plus b squared is equal to c squared, means c is the hypotenuse, a and b are the two sides adjacent to the right angle. So this triangle is going to be a right triangle where the angle c is actually 90-degree and the side length c is the hypotenuse. So in this case, obviously we have one solution, and that is a right triangle. Next we are going to talk about the scenario where the discriminant is greater than 0. When the discriminant is greater than 0, obviously the quantity inside the square root, which is b squared minus c squared times sine squared b, is greater than 0. And from here we can say then b squared is greater than c squared times sine squared b. And if we take square root on both sides, we can say b is greater than c times sine of b. And when b is greater than c times sine of b, that gives us three possible situations again. And what are those situations? Well, b could be less than c, b could be equal to c, or b could be greater than c. And now we are going to analyze each of these situations. So here we are discussing the situation when b is less than c for the situation discriminant greater than 0. Now when b is less than c, if we take square on both sides, then we can say b squared is less than c squared, and then can we assume that c squared has a coefficient of 1, and we are going to write that 1 in terms of sine squared b plus cosine squared of b. So we can write it as b squared less than c squared times, for the 1 we are going to convert that into sine squared of b plus cosine squared of b, and from here can we write it as b squared is less than c squared times sine squared of b plus c squared times cosine squared of b. And then if we bring the c squared times sine squared of b onto the left hand side, then we are going to get something like this: b squared minus c squared times sine squared of b will be less than c squared times cosine squared of b. And then if we take a square root on both sides, on the left hand side we are going to get square root of b squared minus c squared times sine squared of b is less than square root of c squared times cosine squared of b, that can be written as c times cosine of b. So now you see the quantity inside the square root, that square root quantity is actually less than c times cosine of b. So now what would be the value of a then? Well, we know a's value is like this: c times cosine of b plus or minus this square root quantity. So the two possible values of a can be written like this. One value can be written with the plus sign, and this value can also be written as c times cosine of b plus a quantity which is actually less than c times cosine of b. I have underlined point up there, as you can see, we have already determined that the square root quantity is actually less than c times cosine of b that we have determined for this particular situation. So here I am going to write it like this, that within parentheses I am saying that this is a quantity which is less than c times cosine of b. And now if you think about it, we have a quantity which is c times cosine of b outside of the parenthesis plus another quantity which is less than c times cosine of b, but in any case c is positive, cosine of b is also positive, so this quantity is a positive quantity. So the sum of two positive quantities will obviously be positive, so we can say this is greater than 0. That means a has a real value here, so this is one possible solution. So we can say that this is acceptable for a. Now let's look at the second possible value of a. I'm going to write it as c times cosine of b minus, this time I'm going to use the negative sign, the square root quantity which is square root of b squared minus c squared times sine squared of b, and then this can be written as c times cosine of b minus a quantity which is less than c times cosine of b. So here again you see c times cosine of b minus a quantity which is less than that, so again this will give us a positive value. That means a has a real value here, so this is also going to be acceptable. So this value of a is acceptable because it also gives us a positive result here, right? So then we are seeing that there are two possible values of a, that means we have two possible solutions. We have seen that already while we are doing the geometrical analysis. We have seen that there was a situation when b was less than c, we had two possible triangles, the triangle ABC sub 1 and the triangle ABC sub 2. Now let's take the second scenario where b is equal to c for discriminant greater than 0, of course. So when b is equal to c, can we write that square root quantity like this? In place of b, I am going to write c. So for b squared, I am going to write c squared minus another c squared times sine squared of b, and this can be written as square root of c squared times 1 minus sine squared of b. And from Pythagorean identity, we know that 1 minus sine squared of b is equal to cosine squared of b. So we can write it as square root of c squared times cosine squared of b, and that is actually equal to c times cosine of b. So for this scenario, the square root quantity turns out to be c times cosine of b. Now let's see what are the values of a. We know that a is equal to c times cosine of b plus or minus the square root quantity. So one of the values of a here would be like this. If we take the plus sign first, then we can write it as c times cosine of b plus the square root quantity. Let me write it first, b squared minus c squared times sine squared of b, and this square root quantity is actually equal to c times cosine of b. We just saw that up there. So then we can write it as c times cosine of b, which is outside of the square root, plus c times cosine of b, and that is equal to 2 times c times cosine of b, and c and cosine of b, they both are positive, so this is greater than 0, so this is an acceptable value for a. So this gives us one solution here. And now let's take a look at the second value of a. Second value of a can be taken with the negative sign here, so that would be c times cosine of b minus that square root quantity, and this can be written as c times cosine of b minus that square root quantity is also c times cosine of b for this particular scenario, and that is equal to 0. So here we see that the value of a, which is the side length a, is 0, and that is clearly not acceptable for a triangle. The side length cannot be 0, so we are going to say this is not acceptable. So in this case we see that there is only one acceptable value of a. That means we have only one solution, and this was the situation when the point c was coincident on point b for one of the situation which we could not take. During the geometrical analysis, we have seen that when b is equal to c, when we drew the arc, it was going through the point b and also it was cutting bx at another point, and that is the only solution that we could take. Otherwise the point c becoming coincident on point b, that is not an acceptable situation, so we have only one solution here. Next we are going to look at the scenario where b is greater than c. So when b is greater than c, can we write it like this? If we take a square on both sides, we can say b squared is greater than c squared, and from here can we write c squared as like this, and here what is the coefficient of c squared? Well, c squared's coefficient is 1, and I am going to write that 1 like this. We can say this is sine squared of b plus cosine square of b. That's a Pythagorean identity. Sine square of b plus cosine square of b is equal to 1. So we can write it like this. And from here, can we then say that b squared is greater than c squared times sine square of b plus c squared times cosine square of b. And from here, if we bring c squared times sine square of b to the left hand side, we are going to get b squared minus c squared times sine square of b is greater than c squared times cosine square of b, and if we take a square root on both sides, then we are going to get square root of b squared minus c squared times sine square of b greater than square root of c squared times cosine square of b, that can be written as c times cosine of b. So here the square root quantity is actually greater than c times cosine of b. Now let's see what are the values of a. We know that a is equal to c times cosine of b plus or minus the square root quantity, which is b squared under the square root, of course, b squared minus c squared times sine square of b. And from here, what are the two possible values of a? For the first possibility, let's take the plus sign. So we can say a is equal to c times cosine of b plus the square root quantity, and this can be written as c times cosine of b plus a quantity which is greater than c times cosine of b. You see up here, let me underline right here. So we have determined that this square root quantity is actually now greater than c times cosine of b for this particular scenario. So I am going to write it like this. I am going to say, well, then there is a quantity which is greater than c times cosine of b. Now if you look at it, c and cosine of b, they all are positive quantities. So this particular sum right here is definitely going to be a positive number which is greater than 0. So we can say that this value for a is acceptable, because when you are talking about the side length of a triangle, it cannot be a negative number or 0, right? It has to be a positive number, because the side length cannot be a negative value. The side length cannot be 0, then we won't be able to draw the triangle. So definitely the side length has to be a positive number, and in this case we are getting a positive number here, so that means this value is acceptable for the side length a. Now what is the second value then? Let's take a look at the second value of a. For the second value of a, we can say that this will be c times cosine of b minus, this time we are going to take the minus sign, and this can be written as c times cosine of b minus a quantity which is greater than c times cosine of b. And this is the interesting situation. We have to be very careful. We have to clearly understand this, that we are subtracting a quantity which is larger than the original quantity. So in this case, we are going to get a negative value, and this will not be acceptable for the value of a, which is the side length of a triangle. And I have made a note of that. So in this case, again, you are seeing that we have only one possible solution. And during the geometrical analysis also, we saw that when b was greater than c, we were getting a triangle on the left hand side and we are getting a triangle on the right hand side. The left hand side triangle was not acceptable because angle b was becoming an obtuse angle, but we are doing the analysis assuming that the b is an acute angle, right? So we had only one acceptable solution, and through the algebraic analysis also we are seeing that there is only one acceptable solution. Next, let's quickly talk about the situation when b is a right angle. So far all this analysis has been done on the assumption that b is an acute angle. Now we are going to take a situation where b is a right angle. When b is a right angle, I am to make a couple of quick notes here, that sine of b will be equal to sine of 90 degree, which is equal to 1, and cosine of b, that will be cosine of 90 degree, which is equal to 0. And what is the value of a? Well, value of a is like this. A is equal to c times cosine of b plus or minus square root of b squared minus c squared times sine square of b. Now let's substitute the value of b here, the angle b. So we can write it as c times cosine of 90 degree plus or minus square root of b squared minus c squared times sine squared of 90 degree. And if you carefully look at it, the first term here becomes 0 because cosine of 90 degree is equal to 0. So the first term is 0. So I am not going to write it, or maybe let me write it like this. So 0 plus or minus square root of b squared minus c squared times sine squared of 90 degree will be 1. So this is essentially just c squared. So that is b squared minus c squared. And this is giving us plus or minus square root of b squared minus c squared. Now this is another interesting situation. Can we take the negative value for the side length of a triangle? Absolutely not. So the only acceptable value here is the positive value, and that would be positive square root of b squared minus c squared. So this is the only acceptable value here. So if a's value will be square root of b squared minus c squared, then that quantity inside the square root must be greater than or equal to 0. Now if you think about it, if b squared minus c squared is equal to 0, then a will become 0, which is again not acceptable. So from here, the only acceptable situation is that b squared minus c squared has to be greater than 0. And if that is the only acceptable situation here, then from here can we say that b squared must be greater than c squared? And in this case, of course, b and c, they are nothing but side length of a triangle. They all are positive quantities. So if we take a square root on both sides, we can say then b will be greater than c, and that is the only acceptable situation here. So this is the only solution. When b is greater than c, we will be able to draw the triangle. So that is the only one solution here. And during the geometrical analysis also, we have seen that when b was a right angle, the only acceptable situation was that b has to be greater than c, then only we are able to draw the triangle. Now let's take the situation which is our final situation, where b is an obtuse angle. Now when b is an obtuse angle, sine of b will be positive, but cosine of b will be negative. Cosine of an obtuse angle is always negative. Sine of an obtuse angle is always positive. Now what is the value of a? Well, a is equal to c times cosine of b plus or minus the square root quantity, which is square root of b squared minus c squared times sine squared of b. Now if we think about the two possible values of a here, one value will be with the plus sign, that can be written as c times cosine of b plus the square root quantity. And let's think about the negative sign also, the second value of a. The second value of a goes with the negative sign, so c times cosine of b minus the square root quantity. Now if you think about the second value, c times cosine of b will be a negative quantity, because for obtuse angle cosine of b is negative. So this quantity right here, this is going to be negative. Let me indicate that this is going to be negative. So this is a negative quantity right here, c times cosine of b. And also because of the minus sign, this second part is also going to be negative. So this particular value will not be acceptable, because a's value will become negative. So then what is the acceptable value then? Well, the only acceptable value would be with the plus sign. Now again, there is a caveat. With the plus sign again, we have to somehow make sure that the square root quantity is greater than c times cosine of b, because c times cosine of b is already a negative quantity, because b is obtuse angle, right? So essentially we have to make sure that a's value is positive. That means this quantity right here that I have written, a equals c times cosine of b plus square root of b squared minus c squared times sine squared of b. This quantity on the right hand side, this quantity has to be positive. So from here, can we write it like this? And then if we keep the square root quantity on the left hand side and bring the other term on the right hand side, then we can write it like this. Now let's think about the right hand side quantity. Cosine of b is a negative quantity, c is a positive quantity. So negative c times cosine of b will be a positive quantity, and on the left hand side also we have a positive quantity. And because we have both sides positive on an inequality, we can do a square on both sides. So if we square both sides, then it's going to look like this. On the left hand side, we are going to have b squared minus c squared times sine squared of b, and on the right hand side, it will become c squared times cosine squared of b. The negative sign will become positive because we are squaring it. So it will be positive c squared times cosine squared of b. And from here, if we keep b squared on the left hand side, then we can say b squared must be greater than c squared times cosine squared of b plus c squared times sine squared of b. And from here we can say, well, then b squared must be greater than c squared will be a common factor, and then within the parenthesis we have cosine squared of b plus sine squared of b, and we know that sine squared of b plus cosine squared of b is equal to 1. That's the Pythagorean identity of trigonometry. So now we can clearly see that b squared is going to be greater than c squared, and from here we can say that definitely b will be greater than c, because they both are positive quantities. If we take a square root on both sides, then we get b greater than c, and that is the result that we wanted to prove, because geometrically also we have seen that when b was an obtuse angle, the only available option was that b has to be greater than c, then only we could draw the triangle. And here also algebraically we are able to prove that yes, b has to be greater than c for a to have a positive length. So our algebraic analysis is complete now. Next I am going to summarize all of these observations in the geometrical diagrams that I have drawn at the beginning of this video. This first diagram was was the scenario where discriminant was equal to 0 and b was equal to c times sine of b. Now let's look at the second diagram. This was the scenario where discriminant was greater than 0 and b was less than c. And in the third diagram, it was discriminant greater than 0 and b is equal to c. We can see that on the note also on the left hand side. And then in the fourth diagram, we had discriminant greater than 0 and b is greater than c. And this was the scenario where b was a right angle and b needed to be greater than c. And finally, this was the scenario where b was an obtuse angle and here also b needed to be greater than c. That brings us to the end of this video. Hope everything made sense. Thank you for watching. See you in the next video.